Hi, so we're molecular bioengineering year 2 students, and this is our DAP2 project. So we've been tasked with outreach, so we've designed an escape room to target 14... Dude! Hi everyone, we're molecular bioengineering year 2 students, and this is our DAP2 project. So our project is about outreach, and we've designed a bioengineering themed escape room to teach 13 to 17-year-olds more about bioengineering, garner their interest in it, and hopefully get them to pursue it as a career. So for this, our escape room is centered around Dr. James. So something terrible has happened to James. You've got to figure out what's wrong with him, how to save him, and who did this to him. But before that, we've got a little video to set some context.
This is Dr. James, a researcher of bioengineering at Imperial College London. He's currently at a critical phase in the development of his bioengineering research, but he has come across something very concerning. One of his co-workers has been involved in unethical activities related to the use of mind-enhancing drugs. He quickly stuffs the evidence in his safe and locks it with a code. Dr. James cannot believe what is going on and decides to have a lunch break at the famous RSM Cafe to process all that has just unfolded. Whilst eating, Dr. James begins to feel queasy. The world is spinning, and he collapses to the floor.
So for our first bit, we need to figure out what's wrong with Dr. James, and for that we have a mock ECG and vital monitor simulator. So I'll pass it on to my colleagues to tell you a little bit more about that and how you can figure out what's wrong with James.
The role of the ECG is to act as a fun, interactive outreach tool for students to be able to determine Dr. James's condition.
Okay, so our project, for the first step, it revolves around the concept of the 3-lead ECG. Obviously, considering the demographic of 14 to 17-year-olds, the concept of an ECG can be quite daunting, so we decided to simplify it and implement it in the form of a puzzle. So, students will be given this piece of paper which outlines roughly what an ECG does. We go over the concept of the Einthoven's triangle, as well as outlining which limbs are to be connected. The circuit around us has 4 circuits corresponding to 4 different limbs. Now, the job of the students is to correctly identify which limbs should be connected and into which pins they should be connected on the Arduino. For simplicity, we have showed you the properly connected version. As you can see here, readings are outputted as well as an ECG wave, which provides some information on the condition that Dr. James has contracted. Now, on the sheet of paper, we give out some model answers of what the readings should be and what the normal ranges are. So the goal of the students is to compare these readings to what is on the ECG display. For example, the heart rate and blood pressure here are abnormally high, and as well as some physical features such as the rash on the doctor himself. And through these, they gauge the symptoms and are able to determine what he's contracted in the next step.
So once the students have identified the symptoms that Dr. James is presented with, they will then correspond these symptoms to a range of pathogens and identify the correct pathogen that Dr. James is contracted. And also they get to design a drug that will cure Dr. James. They will design the administration method of the drug as well as the mechanism of the drug working in James's body. Once they have identified the correct drug, they will pick the correct drug card, which will open the safe here. So in this safe, they will find a police report and a UV light torch. The police report describes the case James is involved with, and James, as an aspiring bioengineer as he is, has further evidence in another safe. And the code to this safe is recorded in one of his work of luminescent bacteria. And so the participant will shine the UV light torch into this petri dish, and they will find a code to the other safe.
So using the code that's obtained, they will put the code into the lock. Can you? In order to open the safe. In the safe, they will find the gel electrophoresis apparatus, which used in the forensics and paternal test to determine the identity. So they can visualize it with a UV torch. And with those UV torch and the picture, the same thing that's given, they will match up the DNA pattern that's found in a criminal crime scene and the suspect's DNA pattern. in order to find out who the criminal is.
Once they figure out the crime scene data, they can figure out who the killer is, and they found out the killer here. So what they have now is that they have a card that they can take home, which will make it more personable, and they can personalize it with the specific bacteria or drug that they've created, and they can take this home with them. And they also have an information leaflet which has more information about our whole process, and they can have a Q&A session afterwards, so we can discuss the project and see what other improvements can be made and what they've learned.
So all in all, we wanted to create a project that was interactive, memorable, and broke away from passive learning to engage 14 to 17-year-olds to engage with bioengineering. Through doing this project, we really enjoyed the process, and this day has been a great end to the whole 8 months that we've worked on it. The day was really enjoyable. We got to look around everybody's different projects, and we got to showcase all the hard work that we've put in this year.